Hi everyone. I've decided to do a little experiment to see if streaming, what kind of impact I guess streaming would have in the development of Dogen. And the main reason why I thought about doing this is because, like a typical open source project, especially those that are very long term, take a long time to come to fruition. Point in time in the development where you feel like you need to share with somebody what you're up to, really. And it's very difficult to explain to people what it is you're trying to do. So I thought one idea would be to just explain how typical problems are solved within Dogen. And for this, I decided to tackle a problem I'm having at present. So to cut a very long story short, as I explained in my release notes previously, one of the things we're trying to do with Dogen is move away from all the special cases and special types that we have everywhere. As an example, if I look at C++ code generation, you can see it's not actually it. You can see here, for example, that there's a number of things that belong in the C++ model, this namespace that we call fabric. And these types here are kind of hidden away here in the C++ model to do with generation. In reality, this is really a meta type. It should be just like any other type we've got that models something. Like for example, these types in particular are modeling aspects of ODB and ORM code generation. So all these types really should belong to our main meta model, which is assets, which has been tidied up over time. And now you see inside of this model is you see lots of different namespaces representing different aspects of the things we're modeling. So ORM, for example, is here. And so really what we're trying to do now is to move everything across and clean it up and move it to this meta model as it should be. As part of this exercise, one of the things we need to move is the type registrar we have in serialization. So in the past, this was implemented in the C++ model as registrar. Now, in reality, that's the job of this thing is to register types as part of serialization. So we renamed it and cleaned it up into type registrar. We implemented half of the work, and we are trying now to clean up the templates. But once we try to hook everything up together and try to to generate the templates, we found that nothing was coming through, which raised an interesting problem. Dogen provides you with a lot of output at the moment. I mean, if I have a quick look here at the kind of information you can get with Dogen, if you enable all the diagnostics, you get quite a lot of stuff coming out. I mean, not only have the log file, which in this particular case is best part of some 21 megabytes. But in this log file is all sorts of things that tell us what Dogen is up to. In addition to that, we have all the tracing machinery. So for instance here, you can see our transform stats that tells us everything that Dogen is doing in terms of transforms and the chains, everything that's executing inside of Dogen. And you can take information from this file and then plug it back into the log file, and this then shows you where that transform is executing, and then you can follow it through here and find lots of context. In addition, if you want to understand what the file system is doing, Dogen also has a report of operations that tells you what it did to each file and why. However, what Dogen doesn't make very easy for you to do is to figure out if something didn't get generated, why didn't it get generated, right? This is the question we're trying to answer. We have a new meta type, we created some templates for it, but nothing comes out in the code generation. Now, of course, the log file probably has information for this, and I'm sure if you could actually go through this very carefully, you would find information here. But it's just a linear thing, whereas really Dogen is a graph of transforms. So it's very difficult to understand where in the log file one should be looking for this. So instead of trying to solve this as let's just fix the problem for this meta type, it seems like we need a proper solution for this. So the original idea was, okay, can we just extend the approach we've already used that served us really well, and just create yet another report, in this particular case the modeling report. I probably should really start clocking some time here. Whilst that seems like an interesting idea, what we found was that there's lots and lots of different types of questions that need to be asked. And yeah, the modeling report would provide you information. It would probably allow us to figure out the life cycle of a modeling element across the different phases of the pipeline. But it seems like we're creating more and more sort of specialized cases to answer questions that are actually more general. As it happens, we already had done some work on this before, and we had concluded that the future for this sort of approach was to create an actual relational model that generalized tracing. And this relational model, it didn't have to be a really clever relational model, but as long as it could sort of contain all the information of the different models that we are executing, it would be sufficient for us to then write queries and to try to then figure out where things are in the pipeline. And of course you could extend it. It would be a much more extensible model, and you could write PL/SQL queries to clean up things. So as part of that exercise in the past, we created the basis of a relational model. And so part of what I want to do with this series of live streaming, or so code streaming, I guess, is to try to describe how you'd take something like one of these models, convert it into codes, and then plug it into the framework, to the main Dogen framework. So here what you can see is the idea of this relational model is to try to abstract the individual models that we've got. So at the moment the pipeline of Dogen is composed by 3 stages really. The injection stage, in which we have this very simplified model, and then for each of the injection drivers, I guess you could call it, they transform into this injection model. And then this model then goes into the assets stage of the pipeline, which is what I described a second ago, which is the main meta model, where there's lots of transforms that get executed against this model and enrich the model into a state where it's ready to be generated. And then from there we move over to the extraction phase of the pipeline, and the extraction phase of the pipeline is the last bit of the pipeline, I guess. So we've been trying to tidy up the previous architecture that we had into this new world of the extraction. Part of that exercise is the cleanup of these generation models that we have. I mean, we still need a generation phase, of course, but we just need to tie it up to move all the work in the what we used to be called the generation phase that's actually meta model related. So for instance, we have a lot of transforms here that really these expanders were, before we understood that these things were transforms, these expanders really are transforms. And we have, of course, all the metatypes I mentioned before we understood that these things were actually metatypes. So in the future, really, the extraction model will be the last phase, or the last phase in the pipeline, and we still, of course, will have other transforms here within the extraction phase, but they are operating on artifacts rather than meta model items. But the idea is that you should be able to take these 3 phases of the pipeline, and for each of the transforms get a pre and post transform representation and get that into a database, SQL database. And then we can start extracting fields in that SQL database as we require them. And that's the idea behind the relational model. So the relational model has been designed, but never really was implemented because it seemed like a lot of work. I mean, not only you have to create the relational model, which you've done already, but then we have to generate adapters that take each of these models in the pipelines, in the phases of the pipeline, and convert or adapt into the relational model. And then once that's done, and we have got it in a relational database, then we have to start creating queries. We never really had a problem that was complicated enough to justify all this hard work. But really, what we seem to be doing instead is these things we're doing, spending lots and lots of time investigating problems. These investigations are quite costly, especially when we haven't got a lot of time. So it seems that it's probably best to just bite the bullet to try to create a generalized solution for this problem, and then extend it as we go along. So what I'm going to try to do in this series of videos is I'm going to try to describe how one would take this model here, and using Dogen convert this into actual feature that goes into Dogen. This is just the first video that I'm creating. It probably is going to be a very, very long series of videos, really. And I'm sure that the videos are going to last longer and longer as we go along, but this one is probably going to be quite short because, well, first because it's late, and second because it's the first video of the series, so I just want to set the scene, really, and then from then on we'll take it from there. I think that's probably all for today. See you on the next video.